The universe loves to surprise us, and one night, astronomers spotted a faint traveler moving in a way that broke all the local rules. This wasn't just another asteroid, it was something from the vast darkness between the stars. They named it 3I Atlas with I for interstellar. A true cosmic nomad. This object wasn't born of our sun but came from another solar system, a messenger from afar. Imagine a message in a bottle, hurled across interstellar space for millions of years. What secrets did it carry from its distant home? News of the discovery spread rapidly, and telescopes worldwide turned to catch a glimpse. This was a rare chance to study a piece of another world without leaving our own. 3I Atlas was a cosmic puzzle, a brand new mystery to solve. Its path made it clear. It wasn't bound by our sun's gravity, it was just passing through. Scientists raced to learn all they could before it vanished back into the void. Every bit of data could reveal how solar systems form. Not just ours, but all of them. Are the building blocks of planets and life the same everywhere? 3I Atlas offered a chance to find out. It was a cosmic ghost, and we were the ghost hunters, eager to capture its secrets. The universe had delivered a sample from another star right to our doorstep. We see comets all the time, but those are our comets, born from the same material as Earth and forever tied to the sun. An interstellar object like 3I Atlas is a true alien, not orbiting our sun, but ejected from another star system long ago. For eons, it drifted through the galaxy, a silent witness to cosmic history. Studying our comets tells us about our own past, but an interstellar comet is like finding a lost tablet from an unknown civilization. Its chemistry and structure are direct clues about another star's environment. Before 3I Atlas, only 2 interstellar visitors were confirmed, Oumuamua and Borisov. Each gave us a brief glimpse into the wider galaxy. 3I Atlas was the third, and perhaps the most revealing. It was a new chance to compare, to see if the galaxy's building blocks are similar or wildly diverse. Every interstellar visitor is a priceless scientific treasure. The universe was offering us another page from its diary, and we were ready to read. The discovery wasn't made by a lone astronomer, but by the robotic Atlas system in Hawaii, designed to scan the sky for dangerous asteroids. On a routine scan, Atlas flagged a faint object on an unusual path. Its trajectory wasn't a closed loop, but a hyperbola, a one-way ticket through our solar system. The alert went out. Another interstellar visitor had arrived. The Atlas team's patience and systematic observation paid off. Once announced, astronomers worldwide sprang into action, eager to study this cosmic puzzle. The object was faint but predictable, allowing scientists to plan their observations. This wasn't just about pretty pictures, it was about using spectroscopy to reveal the comet's chemical makeup. The quiet, robotic discovery in Hawaii had kicked off a global scientific sprint. It was a triumph for the Atlas program and a perfect example of how science works. Careful measurement, collaboration, and the thrill of seeing something no human has ever seen before. The world's telescopes were now focused on this rare visitor. The race to unlock its secrets had begun. Most objects in our solar system travel in ellipses, bound to the sun. 3I Atlas, however, was on a hyperbolic path, an open curve, proof of its interstellar origin. It came in fast, swung around the sun, and would be flung back into interstellar space. Our sun's gravity could bend its path, but not capture it. The rarity of such events makes them precious. Space is vast, and the odds of spotting such a visitor are astronomically small. When we find one, it's a major event, a pristine sample from another star's nursery. These objects are time capsules, perfectly preserved in the deep freeze of interstellar space. By studying 3I Atlas, we could learn about conditions in a completely different part of the galaxy. The race was on to observe it before it slipped away forever. Its hyperbolic trajectory was the golden proof. This was a true interstellar traveler. Every observation was a chance to unlock secrets of the wider cosmos. The opportunity was fleeting, but the potential knowledge was immense. Scientists coordinated globally to maximize every moment. 3I Atlas was a once-in-a-lifetime visitor. The world watched as it sped through our solar system. While Earth's telescopes tracked the visitor, a unique opportunity emerged millions of kilometers away. China's Tianwen-1 spacecraft, orbiting Mars, was designed to study the red planet, not hunt comets. But as astronomers plotted 3I Atlas's path, they realized it would pass near Mars, within Tianwen-1's field of view. This was a cosmic coincidence, a state-of-the-art probe, and an interstellar object in the same patch of sky. Repurposing a Mars mission for comet hunting was audacious. Tianwen-1's instruments were built for Mars, not deep space, and pointing them at a faint moving comet was a huge technical challenge. The commands had to be written, tested, and sent across vast distances. There was risk, but the scientific payoff was too great to ignore. Observations from space avoid Earth's atmospheric distortion, and Tianwen-1 was in the right place at the right time. The CNSA team rose to the challenge, deciding to turn their Mars orbiter into a temporary interstellar observatory. The stage was set for a remarkable astronomical observation. Humanity was about to witness an interstellar visitor from a whole new vantage point. The world watched as China's probe prepared for a cosmic encounter. Science thrives on seizing the unexpected. Making this observation happen was a technical ballet. Mission controllers had to calculate the orbits of both Tianwen-1 and 3I Atlas with extreme precision. A tiny error would mean missing the comet entirely. The comet's light was faint, so exposure times had to be perfect. Tianwen-1 had to pivot away from Mars and point into deep space, a task it wasn't designed for. All commands were sent across millions of kilometers, with no second chances. The tension in mission control was palpable as they waited for data. Then, success. Tianwen-1 reoriented, opened its camera, and captured the comet. It was a triumph of ingenuity, and a moment for all humanity. A robotic emissary had witnessed a visitor from another star system. Data streamed back across the solar system. Images and information no one had ever seen. The cosmic message in a bottle was about to be opened. Science had pulled off the improbable. As Tianwen-1's data arrived, scientists were stunned. 3I Atlas was changing before their eyes. Far from the sun, it was reddish, a sign of eons in the deep freeze. Its surface cooked by cosmic rays, but as it neared the sun, the surface heated up and ices beneath began to sublimate, creating a glowing coma. The comet was waking up, coming alive after its long interstellar slumber. Most stunning was the color shift. The coma glowed bluish-green, a sign of molecules like diatomic carbon and cyanogen energized by sunlight. Tianwen-1 wasn't just taking pictures, it was doing chemistry from millions of kilometers away. This real-time transformation showed the reddish crust was only skin deep. Beneath lay volatile ices, much like comets from our own solar system. It was powerful confirmation that cometary building blocks might be universal. The chemistry around a distant star might not be so different from our own. We were witnessing the activation of an interstellar comet for the first time. The universe's recipe for comets seemed to echo across the stars. The discovery of 3I Atlas gave us a crucial new piece in the puzzle of interstellar objects. Compared to its predecessors, Oumuamua and Borisov, each told a different story. Oumuamua was mysterious, small, reddish, elongated, and showed no coma, yet accelerated away from the sun. Borisov looked and acted like a classic comet, with a familiar composition. 3I Atlas bridged the gap. It arrived dormant and reddish, then transformed into an active, glowing comet. For the first time, we saw the process connecting these states. Perhaps Oumuamua was just a more depleted version, or one that never got close enough to the sun to turn on. 3I Atlas became the missing link, a Rosetta Stone for decoding these messengers from the stars. Each visitor expands our understanding of the galaxy's diversity. The story of interstellar objects was coming into focus. Why does this matter? Because it touches on the deepest question. Are we alone? Comets may have delivered Earth's water and the organic molecules needed for life. 3I Atlas, observed by Tianwen-1, glowed with the signature of carbon-based molecules. This interstellar visitor carried the same fundamental chemistry as our own comets. It suggests the raw materials for life are widespread, not unique to our solar system. The universe appears to follow the same chemical recipe in different kitchens. Every star system might get a starter pack of life's ingredients. This collaboration between Hawaii and China is a testament to science as a unifying human endeavor. 3I Atlas is now heading back into the void, but the data it left will be studied for decades. It leaves us with wonder, a sense of connection, and hope that the story of life may be written among the stars. The cosmos is full of possible worlds. We are just beginning to read the first chapter.